Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. This video is continuation for multiple spam detection models. You can watch the previous video available on YouTube. Then comes the support vector machine. Let's see the example. Imagine drawing a line on the ground between two groups of people, so group A and group B, such that everyone in group A stays on one side of the line and everyone on group B stays on the other line. SVM finds the best line to keep the group separate. So what is happening is line in the middle, one group on the left, one group on the right. Line in the middle, one group on the left, one group on the right. This is what happening in support vector machine. Imagine a plot of emails with spam and not spam as two groups of points. So you can divide the emails in two groups, spam and not spam. SVM will find the line that best separate these two groups. If the email you receive falls on the spam side of the line, so if the email you receive falls on the spam side of the line, SVM will classify it as spam. So it will just detect where it is falling and it will group it accordingly, spam or not spam. SVM tries to find the best boundary or hyperplane that separates the data point of different classes. It maximizes the margin between two classes, making it robust choice when there's a clear separation between classes. So here we have clear separation. Either the mails can be spam or not spam. So you can divide it into two group of points and then it will detect, this model will detect whether to keep it as spam or not spam. Again, very easy code. See, this is the code using sklearn, easy code. So decision tree, very easy concept. It's just I have already told this in previous session. It is in the form of tree having branches, different branches, so it creates a tree like structure. This is what it is. So let's see the simple example first. Imagine you are trying to decide whether to take an umbrella with you. You make decision based on questions like, is it cloudy or is it raining? Based on the answers, you will eventually come to a conclusion, take an umbrella or not. So what you will think, looking outside the window, is it cloudy? Is it raining? And based on the answers, you will eventually come to conclusion like take an umbrella or not. So this is the simple example of decision tree. Let's see the level 2 in the context of spam detection. Imagine a decision tree where the first question is, does the email contain the word price? So does the email contain the word price? If yes, it might go further and ask, does it contain a link? So if it found the price, if yes, it will go, does it contain a link? Based on the answers, it will classify the email as spam or not spam. And if you forgot about decision tree, I will again show you decision tree, how it looks like. So should I accept a new job offer? This is what this decision is all about. This is the parent node, and based on your yes no decisions, branches will go on. So salary at least this, then yes, commute more than 1 hour. If no, decline offer. If yes, then commute more than 1 hour. If they say yes, then decline the offer. If they say no, offer free coffee. Do they offer free coffee? No, then decline the offer. If yes, accept the offer. This is how decision trees work, and this is how it looks like. So let's see this in context of spam detection. Imagine a decision tree where the first question is, does the email contain the word price? If yes, it might go further and ask, does it contain a link? Based on the answer, it will classify the email as spam or not spam. This is how decision tree will work. And decision trees classify data by splitting it based on feature values. It creates a tree like structure where each internal node represents a decision based on features like certain words in an email, and each leaf node or child node represent the final classification, spam or not spam. So if I open the image, so these leaves, or these are called leaves here, or child nodes. So depend upon the decision you are making. It helps in making the decision whether the email is spam or not. This is what decision tree is. This is a really simple concept, decision tree, and this is how you use decision tree. Again from sklearn. Let's look at the last one, that is random forest. Again, this is not very complex, very easy. It is just the extension of decision tree, or random forest is an ensemble of decision tree. Imagine you have 10 friends and you ask each of them whether it will rain tomorrow. 8 of them will say yes. So suppose you have another example. Suppose you have 100 decision trees, 100. Each tree votes on whether the email is spam or not. If most trees say it's spam, random forest classify it as spam. So what it will do is, it will ask for multiple trees. It will ask multiple trees for the answer, and if most of the trees decision trees will say yes, then email will be marked as spam. This is how this algorithm works, random forest. Or random forest, it builds multiple decision trees using random subsets of the data and features, then combine their results. So after all the computation, it will combine the result. This reduces overfitting and increases accuracy by averaging the decisions of many trees. So more the trees in the random forest, better will be the result. This way this will happen in real world. More the decision trees, better will be the result. How to implement it? This is very easy. Again, this is random forest, sklearn. So everything is available in sklearn. This is how you use, and this all will happen after the vectorization. After the vectorizer, this all will happen. Now comes the summary. So logistic regression. Okay, so logistic regression, like a weather forecast that gives a percentage chance of rain. If it's 90% likely to rain, you prepare for rain. This is what logistic regression is. KNN, like asking your 5 neighbors whether they think an email is spam, and you go with the majority opinion. This is what K nearest neighbors is. SVM, like drawing a line on the ground that separates spam and non-spam emails, and checking which side your new email land on. This is SVM. Decision trees, like playing 20 questions where each yes or no answer narrows down whether the email is spam or not. This is what decision tree is. Random forest, like having multiple decision tree and letting them vote, the majority decides if the email is spam or not. This is random forest. And to implement this, I have also mentioned it in form of cluster or modules also. I will show you. See this, have mentioned the modules also like this. If you want to see the code, different code for each model, you can see it like this. Again, when to use what, this will be the best example. See, what I did is implemented all the algorithms or these models in one single program, and this way I can check which one is performing the best. So see, logistic regression 98.67, you can look for all these metrics, and see this one 95.84 KNN, SVM. See, you can pick the best using this classification report. How to read it, I have already mentioned this in the article. You can check for it. This marks the completion of multiple spam detection models. I will see you in next video. Have a nice day.